Bye-bye.
Hello, Mr. Rainer, right?
Maybe
Okay.
not.
What's 15 in binaries? Do you still remember? 15.
1 1
1 1 1 1 1 1.
Where
1
down?
1
1, 1, 1, 1. Okay, what's 14 in binary?
1 1 1 0.
And 13 is 1 1 0 1, right?
1101, yes. Okay, so let's say how many bits, bits is just 1 or 0, right? How many bits are different?
1.
We talk about this Hamming distance. The definition. Do you still remember the definition of Hamming distance?
It's when you use a hammer to find the distance.
When you use the hammer to find the distance. Can I have this, please?
Wait, I got it. It's mine.
So the Hamming distance
It's a nice fan.
is the number of different bits. Okay? So the Hamming distance for these two is 1 because there's only one bit is different. Am I right? Okay? So what's
Yeah,
the
but
Hamming distance? What's the Hamming distance for
It's
this?
not
6.
Yeah, so
6.
the 6 bits are different, right? This is Hamming distance, okay?
Yes.
Okay, and we know how to calculate the Hamming distance into
Is
using
that?
Yes.
what's
Oh
that?
yeah.
This one, this
One.
one, this one, this one, this one, this one,
No, not that one.
this one, yeah. This one.
Otherwise, if that one is, it'll be 7.
Okay. So how do we find the Hamming distance of 2 bits, right? If this is A, this is B, how do we calculate the Hamming distance?
We just.
This is
But what if they're different amount of digits?
that's a very good question. That how about
Like 1 and 1 0.
yeah,
That
because
means
this is
that's then 1 because nothing against 0.
like
That's
that,
the
right?
difference.
So this is 1 and 1 0, right? So there are two bits are different.
If it's
Look, they are leading zeros, right? Which is omitted, which are all zeros. Okay. So these 2 bits are different, so it's 2.
Yeah, but these people are the same.
they don't count.
They don't count. The different, we count the different bits. Okay?
Okay.
Yeah. How to calculate? How to count?
We do subtraction.
How to count?
We
So-
do maths.
Yeah, math. Which operation? Do you still remember? Which operations will return 1 if both are different? Look, this is binary. Do you still remember this? This one is OR, right? One of them is true, then it's true. If 1 and 1 is 1, 1 and 0 is 0, 1 and 0 is 0, 0, 0. And what do you call this? This is called N.
If one of them is 0.
Yeah, N, right? N means that both needs to be 1 in order to be 1, otherwise it will be 0, okay? So here, we want it to be different to be 1, okay? We want it to be 1 and 1 to be 0, 0, 0 to be 0, and these two be 1, am I right? Look,
Whee!
these two be 1, okay?
Yeah. Whee! Oh, it's mine.
So-
Jesus.
So this is A, this is B, and this is C, okay? So A and B needs to be different in order for C to be different, right? We call this exclusive OR. What's the difference between OR and exclusive OR, okay?
So or is when if one of them is 1, then it's true.
Okay.
And then for exclusive or, if both of them are the same, then it's false. If else, then
it's true.
true.
If different, it's true. We're given two numbers, A and B. We want to find out the minimum number of flips to make one to the another. For example, like 1, 1, 1, 1, and this is 15, right? 13, let's say 13 is 1, 1,
1 1 0 1.
0, 1. So what's the number of minimum flips to make one to another?
And 11 is 1 0 1 1.
Yeah, how many flips do we need to make to flip into another?
And
What do you mean by
and
flip?
7.
That's a good question.
and
Flip is 0 to 1 and 1 to 0.
And 7
I
is
said
1
1.
1, okay.
And 7 is 1 1 1.
Okay, 7 is 1, 1, 1, right? 8 is 1, 0, 0, 0, okay? How many flips?
4.
4 flips, yes? Okay, that's true, okay. What's this number? At the very beginning of this lesson, I mentioned a concept which is called edge distance. What's this?
Hammer.
And you mentioned about
Hamming.
Hammer.
Hamming distance, okay? What's the Hamming distance definition? Remember? The number of
Hamming.
The number of what? The
Living.
number
Nail.
of different
Numbers.
bits, right? This is called Hamming distance, okay?
Different digits.
Different digits. Is this the answer, the Hamming distance? The minimum number of flips?
Yes. Yes.
The Hamming distance is basically the same as the number of flips, right? The number of flips, because if it's a bit is different, then we need to flip it. So the answer is just the Hamming distance. So let's calculate the Hamming distance using exclusive OR, just like that, right? Define, okay, let's flip A and B. Two numbers, right? This is returning the integer. Hamming distance, D equals A exclusive OR. How do we represent the exclusive OR in Python? Exclusive OR.
XOR.
That's good, but using this. What's this? This is the symbol at the number 6, above number 6, okay? So 6 here, right? Yeah, okay? This is the exclusive OR.
Yeah.
Now we want to count the ones, right? Remember, the exclusive OR returns 1 for different bits. Okay, the exclusive OR will return 1, 1, 1, 1 because each bit is different. Right? And then we want to count how many ones. So we can return bin. We're using the bin function. Bin here, this integer will return 0b1111, which is a string because it's converted to binary. And then we just need to count how many of ones. Okay, and that's it, right? Okay, this is one way using the binary function, bin function. Right? Bin stands for binary, not the bin, not the rubbish bin. Okay?
Of course.
We have this D, so how do we calculate? How do we count a number of ones in the binary? Right? 15. How do we know this is 15? How do we calculate? The number of ones is 4. This is the integer. This is the binary.
You do 1 to 4a backwards.
There are quite a few ways, right? One way is using this bin, right? 15. How do we know it's yeah.
Because
Yeah.
That's 1 because backwards is 1, and 2 is 1 to 0 because backwards is 1, 2, but the U is a 0, so you don't count that. So that's 2. And 3 is 1, 1 because that's 2 add 1, which equals 3. And where was I? And
You're backward. Yes, something to do with backward. Okay, I'll show you. Come on, I know what you're talking about. 123. How many 2s are in there? How do we know there's only 1 2?
Because you can't just see it.
Yeah, but computer don't see it. How does the computer know it? How do we know there are only 1 2 there?
Because you know if it's divided by 2 is 1.
No, there's 2 in the tenth. So we know we can do this, yeah? We can look at this last digit. It's not 2, right? We get rid of it. Now it becomes 12. Now this is 2, okay? I increment 1.
yeah,
I get
they're
rid of
looking
it.
at it.
Yeah,
Yeah?
that's looking at it.
No, I'm
Then how do you
taking...
know it's a 2 there?
Yeah, but for computer, we just look at 1 digit at a time, which is the least
Yeah,
significant
that's
digit.
looking.
Okay, I know, but...
Looking.
So, coming back to this, right? 1, 1, 1, 1. How many ones? We take a look at this. This is 1, right? We get rid of it. This is 1, we get rid of it. This is 1, we get rid of it, okay? Etc. Okay? So 15, how do we convert it to binary? 15 divided by 2, which is 7, remaining 1. 7 divided by 2, which is 3, remaining 1. 3 divided by 2, which is 1, remaining 1. 1 divided by 2, which is 0, remaining 1. Okay? When we get a 0, the remaining, we write it this way. So the binary for 15 is 1, 1, 1, 1. Make sense? Let's take a look at 13.
3.
Yes, 3. Okay, 13. What's the binary for 13?
1, 1, 1.
1, 0, 1.
Okay, look. 13 divided by 2. Binary, right? 6 remaining 1. 6 divided by 2.
Why?
6 divided by 2. 3 remaining 0.
Yeah, but 6 divided by 2 is 3 remainder 0.
Yeah. Okay, put it here. 3 divided by 2. 1 remaining 1, right? 1 divided by 2 is 0 remaining 1. So the answer is 1, 1, 0, 1. Okay? Makes sense? Huh?
So yeah, that's 2 times 6 is 1, and then it's 3. Where did the 3 come from?
These three?
Yeah.
No, divided by 2, remaining 1. Divided by 2, remaining. Okay, so this is binary, you divide it by 2. How about decimum? Right?
Why is one divided by 2?
When we get a 0, we stop. Yeah. Okay, we write the remaining in the opposite order. Another example.
100.
100. Divided by 2. 50, remaining 0. 50 divided by 2. 25, remaining 0. 25 divided by 2. 12, remaining 1. 12 divided by 2. 6, remaining 0. Divided by 2. 3, remaining 0. 3 divided by 2. 1, remaining 1. Divided by 2. 0, remaining 1, right? So it's 1, 1, 0, 0, 1, 0, 0. Let's verify.
How come?
How come what?
How come 6 is here, 1. 6 is here, 0. There's 6 here, and then it has a remainder 1.
Actually, no. Actually, it's shifted a little bit. Okay, that's a good point. Okay, so I should write it here.
Yeah, that's what we're saying. That 6 will have a remainder of 0.
While D, then we can do this. Answer plus equal 1. D equals D and D minus 1. Okay, and then that's it. Return answer. This is one way. Of course, there are many ways. We just talk about this. Okay, look. Why D is bigger than 0, we increment, because if it's bigger than 0, then there must be at least 1, right? At least 1, 1. And then we do this. Okay, this is the thing today. Last thing we talk about today. D equals D and 1. What's this? Suppose I have a binary. 1, 0, 1, 0, 1, 0, 0. This is D, okay? What's D minus 1?
D minus 1 is
We don't know.
1, 0. What's D minus 1?
1.
Okay, 100, D minus 1. What number plus 1 equals 100?
99.
There's no 99, this is binary. This is 4, right? Minus 1 is 3, which is 0, 1, 1, okay? 100, 1000 in binary, this is 8. What's minus 1? A minus 1? 7. What's 7?
1, 1, 1.
0, 1, 1, 1, okay? So, what's this? Minus 1.
Is it like
Is it what? Is it 1, 1? Is it 1, 1, 0, 1? 1, 1, 0, 1.
Is it that part?
No, is it
1, 1, 1, 1?
Yeah. And this part is the same, right?
Yeah.
Okay, what's the n? If I do the n, remember what's the n? What's the n? N, this number, and this number, perform the n.
Let me think.
What's n?
0. 0, 0, 0, 0, 0, 1, 0, 0, 1.
Okay. So look, this is D. This is D minus 1. If I perform D and D minus 1, I will get this. So what does it mean? What does it mean?
C, E,
What does it mean here? Look at this bit. So it means that I removed the rightmost one. Make sense?
Yes.
Can you imagine? D
Right.
and D minus 1 is basically saying I want to take the rightmost one, which is this bit, and change it to 0. D minus 1. If I perform an AND, this is actually means that let's look at the number D here and find out the rightmost one, which is here. Okay? I want to get rid of it. I want to flip it
Okay.
to 0. So I can do this D and D minus 1. Why? Because D minus 1 is basically this 1, right? Flip it, minus 1, and all the ones, right? Since this is 0, this is 1. Perform an AND. This becomes 0. 1 and 0 is 0. The remaining will be stay the same, right? Okay, so now here, D and D minus 1. Right? This is the same thing as D and equal and D minus 1. This is basically, okay, I want to remove the rightmost one because that's one flip, okay? One flip and increment it. Okay, then I flip it, okay? I need one flip, okay? I need one flip, okay? I need another flip. I need another flip, and that's it. I only need 3 flips, okay? Make sense? Okay? Yeah, let's look at this example again. A equals 10101. B equals 1 1 0 0 1. Okay. A exclusive B equals what? 0 1 1 0 0, right?
Yeah.
This is exclusive. Okay, let's look at this exclusive. I want to take the rightmost one. Yeah, here. Change it to 0. One flip. Take another one. One flip. Okay, that's it. It becomes 0. Now 2 flips. The number of flips to make one to another. This is also called Hamming distance. Okay. The time complexity, because these t integers are, let's say the integer, if it's unbounded, it's just log n, log 2 base n, right? Okay. If these numbers could be arbitrarily big, right? Because we convert it to binary, we're just performing the bits. Okay, what have you learned today?
We learned about these binary.
The Hamming distance.
Hamming distance is when two numbers.
What's a Hamming distance?
Hamming distance is
When
where
two binary numbers are the same.
Hamming
We just leave
distance
it alone, but if they're different coins, then the number of it is the Hamming distance.
seeing how much there's to change to different bits.
Yeah, the Hamming distance is the number of different bits, okay? And then the question today is the minimum number of flips to change one number to another. So this is basically asking for the number of different bits, am I right? Yes?
Yes.
Okay. So we use D and, okay, so can you explain to me what's D and minus 1? D and D minus 1.
It's basically making D the most right one changing into 0.
Well done. That's it. Yeah, that's it. This is the key part today. Okay, D and D minus 1 and exclusive of A and B are different. Then the exclusive result is true. So one exclusive one is
False.
yes. Good job. Bye bye.